Welcome to this video about the Animator editor, another one in a series of the editors. The Animator editor is, as the name suggests, the main part to create your animations with. In general, this works by creating on one side pre-canned animations in Blender, for example, and exporting them as an animation file, and using an animator to put together these various animations together with programmatical functions and so forth. So an animator is more or less the glue that creates a final animation out of various pieces of single animations you have created yourself. So let's have a look at that one here with this little test model. So here it is. In this example, I have already a bunch of animations created. So this model, for example, has one animation file which contains the individual animations. So an animation file contains one or more moves, and these in turns you can then mix together. You can see this on here. So the various moves in the file can be put together. In general, you can use one animation per animator, and if you need more, you can mix them together. So first, the controllers. This is a basic idea behind animators. It separates the programmer or the coder from the animator artist. So the only thing the artist and the coder need to know is what controllers there exist, what value ranges the controllers have. From that point on, the coder can simply manipulate the controllers without having to know how the animation is created, and on the other side, the animator does not have to know how his animator is used in a program. He just has to know what are the controllers. So that's the basic interface between these two groups of people in the development team. So no further knowledge is required in general. So a controller composes of a name. It's descriptive. You can either link to names or indices. That depends on the programmer. So both are shown depending what you like more. Now, a controller always has a range, and you can use whatever range you want. So the coder can simply say, I need that range, and the value is mapped from 0 to 1 into this range. So for the artist, it doesn't matter what kind of values the coder would like to use for the controllers. The animator only sees 0 to 1, whereas the coder sees these ranges. So it can set values from -30 to 30, and it just works. You can use any kind of logic for a controller. So can you use linked to time or just fixed values. That depends on the coder. These values here are just for testing purpose in the animator. They are not taken to the game. There you simply set these values on your own. But for testing you can select them here, it's easier. In general, a controller composes of the value and optionally a vector, which is after used for inverse kinematics and such. But in general it's a value that is set to a controller. And for testing purpose you can also link it to different animation locomotion parameters, but that's for testing, so it doesn't work for all meshes and all models, but in general it just gives you some testing animations you can test your model with, and these are simply mapped to the controller using these values. In the game this is completely different depending on how your coder works. You can also clamp the values. If they are clamped, it stays from minimum to maximum, and if it's not clamped, it wraps around. So for example, playtime needs to wrap around, as you see here. Values can also be frozen. That's also for in the game. For example, we do not want to change the controller anymore, and you can use it. So once you have the controller, you need a link. That's how the artist feeds a controller value into the animation rules. This simply takes a curve. For this way you can define all kinds of curves for whatever you want. like this one here, and it simply maps the controller value to a new value from 0 to 1, which you can use in your animation rules. It just makes it a little bit easier to create complex animations from a simple set of controllers, so the artist is really separated from the coder. You can also do simple animations with them if you really want, so theoretically one could go and say I make here my own curve, but that's not really the idea behind it. It's possible, but you should not rely on it. Usually it's simple shapes. Once done, you can create your rules, and in these rules you have targets and links. So the targets are simply where you can assign a link to. For example, the source vector would say the value which is used for blending that rule together with the previous rules. And then you have the list of links and you can assign them. Important is you can use more than one link for the same target. And if you have more than one, the results of the individual links are simply multiplied. So you can easily make situations where you would like to have multiple links apply. For example, if a move would have here also for crouching, you could assign a secondary one which then is superimposed. This one doesn't use multiple links per targets, but in your most animations you will do, it's usually required to have multiple influences multiplied together. Every rule has a list of bones you can use. So if no bones are defined, the rule affects every bone in the mesh, and if you make here a list, it will only affect those. So for example, in this case here, only these would be affected, or looking up down, you only want these bones to be affected. You will need this if you want to make complex animations. In general, I'm working with the animators as a list of rules that are applied from the top to the bottom. It's a little bit more like in Blender. It's not a node system, since for most animations node systems are a bit over complex, and if you need really to mix animations together, you have the possibility to use so-called sub-animator. A rule with a sub-animator simply takes another animator, applies this and uses the result. So you can theoretically make trees of rules using sub-animators if it's really required. But usually the idea is to have a list of rules that are applied one by one, with which you construct your final animation. It's rather simple to handle. In most situations you get away with one or two rules you can simply put in. Now, in general, you have a bunch of rules you can apply. An animation, for example, applies your animation at a given time or at a variable time using a controller to the bones. Then the next one is the animation difference. It takes two animations, each with their own time. Leading and reference time are also controllable, and it will apply the difference between the two animations. So you can, for example, say you take a reference animation and an animation which is different from this reference animation, and this difference is then applied. So I can say I have an animation where, for example, you can see it with this tilt up down. I can use the same animation or difference. In this kind it's the same. The middle point defines the normal position, and the 0 and 1 extreme points would, for example, define the animation where it's the floor tilted to the left or to the right. And using the controllers I can shift between these animations, and only the difference is applied. So I can impose this difference on an already existing animation. So it might be a little bit look strange, but it helps to, for example, say I have already an animation and I have now a difference which makes, for example, the head look to the left or to the right, and no matter what the base animation is, this difference is correctly applied. That's the basic idea behind this system. So for example, tilt up down, I should be able to show it with that one, so you see how the difference is applied, and it just works no matter what the basic animation is. It's simply applied on top the animation. So that's the basic idea behind it. Now what have we next? Bone rotator. As the name says, this takes the bones and rotates them all in a direction. I take now, for example, where's the head? Where's the head? Oh, come on. Here it is. Let's say I can take this, then I could go and make it rotate depending on what I want. And I can do this in different spaces where I want to rotate it. That would be the bone itself, or using a rotation bone like this one here. That's the breather bone. So the animation is relative, the rotation is relative to this bone. So there is all kinds of possibilities, and I could rotate or also dislocate depending on what I need. The rotation can be controlled using a controller. This is usually what you want to do, for example, to apply corrective rules to your existing animations. Typical case is for looking up down, for example. I have here look up down. This simply rotates bones up and down and left and right. So these are not animations but bone rotator rules. They are quite versatile for simple stuff, like also, for example, if you have a turret on a tank, for example, you can rotate them using a bone rotator or directly using a state manipulator. This is this one here. State manipulator simply applies a fixed state to all. Oh, come on, where it is again? I'm on the wrong one. Applies a predefined state to all listed bones. So for example, I can directly say what the rotation is or where the position is, for example. So I can directly apply this to a bone. That's usually the case for simple bones you want to animate, like I mentioned, a turret on a tank, for example. This works the same. You can control the individual position, orientation or size between the minimum and the maximum. So it's always a range you can manipulate. Inverse kinematic, I'm not going to say much about it. It's exactly as the name says. You can define a chain between two bones, and the system uses this as a chain from the parent bone to the child bone and applies a goal to them. And the goal that it's simply this vector I mentioned, taken from the controllers. So you can directly say where something is. So let's say I pick, don't know if this is now going to work. Let's pick neck 1 and neck 5, for example. And let's put the goal a bit upside and a bit front side. So that's just your typical inverse kinematic here at work, in this case on a chain from here to here. So typical. And if I assign a controller to these individual positions, it would take the vector of this controller instead of these values here. I could also use a solver bone, like for example, I don't know if this is going to work here. Let's put it in. So that should actually be, so I put the breather on. Let's put it a little bit front, so it uses that bone to target the chain. That's now a little bit strange, come on. So something like that. So it takes now this breather bone again and uses this as target. Then we have also stage snapshot. That's a little bit special. That's only for in-game, so you can take a snapshot of the current animation and apply it later on into an animation. So you can like make a snapshot and come back to it using, I don't know, a blending or whatever. You can programmatically control. So you can say take a snapshot now, and then it's kept in memory. You can also say use the last animation state. So you could introduce, in this situation for example, this would introduce the animation that existed before you started with the first rule. I would apply again here. This might be useful in some cases, but this is a little bit a more special rule. For end state is a little bit like the state manipulator, but it takes the state of a reference bone instead of a predefined value. But otherwise it's the same as the state manipulator, but this allows also to mix together. So if I take this goat head again, once again, I could say I use, for example, the tail is wiggling around. Let's take the breather again. Where is it? Here. So I can say I make only the orientation, but I could say in what frame I evaluate these different values here. You can also scale them. So I can also mix to some degree together. This is usually the rule you want to use if, for example, there would be clothes on and there is a spike on clothes. Then I could use the state of the arm bone to also correctly adjust this piece on the cloth, which by itself would not have been animated by the base mesh. That's mostly for this situation, but could also be used to copy states around. The sub-animator is what I said. You can simply specify a different animator file and implement it into this position. With this you can make trees of animations if you want. Theoretically you can make a super animator which controls all your individual animators with a large list of controllers. It's not handy perhaps, but it's possible. Because I can say here, can assign the controllers from the parent to the sub-animator. So I can control the sub-animator with the controllers I already have. So yeah, it's quite versatile if you really need this kind of control. I use this, for example, in the main character where I have walking and different kinds of animations I use a lot across different animators. I've packed into individual animators and I stash them in using a sub-animator. So you can also sort of make libraries of animators and plug them in this way. You can do a lot of things with it. Then you have also touch ground. It's a little bit of a special one which is used for inverse kinematics. I'm not going to show since it is only useful for scripting. And track 2 is something similar. It simply takes, looks funny, let's put this poor guy out of misery. So I can simply track bone to another bone and adjust the axis with which I track what's up and so forth, what is tracked and what is locked. So it's a typical track to constraint, you know, from Blender for example. So that's for the rules. You can with these create your animations, and for testing you have also some playground. You've seen this quickly. This is simply to quickly test how this all works. So it's really just for the animator to have a quick overview. You have here also visualizations. You don't need them right now, that's work in progress, but it should help to make stuff like feet on ground, inverse kinematics and such, but it's work in progress. And last but not least, you can use camera attachments. This is mostly useful if you have, for example, first-person view models. In this case, you can also use it to test how a first-person model would look like. So you could simply use that model, and it gives you already a movement pattern, and you could check it out. Or if you have, like I'm using cameras directly attached to models, that's to test for. And then we have also animation speed. This way you can, for example, slow down time to check if your animations are working precisely, like this for example. So that's useful. Theoretically you can also make it faster, but that's not really useful. I mean, yes, Benny Hill style, but might be useful to check if your animation works also in these situations. Then you have this attachment stuff. So you can also test if attachments work with your model, with the animations you want to do. So let's do flame here. You might already guess what's going to happen. This guy is missing something. And then you can attach them to the different positions. So, and now he's got a tail flame. So this is, for example, an object which has a particle emitter. You can attach all kinds of objects that are defined in your game definition this way. And you could also adjust the parameters. That's for testing, so it's not saved, it's just for testing. So you can see does things work and so forth. So here is my little flame. Shika, 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 shika. And you can also test using this way, I call it dynamics. Let's pick something strange, like this lamp. You don't see it yet, I have to adjust the position here. Tack. Let's put it at a little bit more. So now here's a bearded dragon, and this way I can also check how objects that are attached, dynamic objects, would work. So you have a lot of possibilities to check directly if something works with your animations or gets into problem. And this one has also light, so I could also go and say, hey, how does it work like if, for example, I attach a light to something like this. So who needs Flash if you've got a Charizard with a light on his nose? So oops. Then last but not least, you have also the wakeboarding, and that's a little bit something special. I will make it quick. It's more or less about what you perhaps once saw. If you want to test how an object reacts to different underground situations, then you can use this. It's just a little test case where you can use to check out how an object adjusts to an uneven floor. So, but that's just more or less for animations, walking and such animations, to check out how it works. So that's not quite everything. Last but not least, you can also check out your bones. That's nice to see if your animations are getting somewhere or not, so you can examine how your bones are exactly looking in the current state. And also adjust the size if you want to need it, or if a model is larger or smaller. Okay, that's it for this time. Next time I will show another animator and another editor, sorry. And in the meantime, I am wishing you a good day. See you!